Okay guys, my video, I get to take my liberty. So my liberty for this is concrete. So this is going to be the floor, the deck, the formwork that I'm going to pull out. So let's go ahead and put some concrete in there. Because I want you guys to see what it looks like. And so as we do that, I want to get you guys over there and take a peek at that, and you can start putting it together in your mind how this should work under tension and compression and all this stuff like that. Maybe it won't come out that good, but the idea behind it, your mind, I mean. But let's go ahead and try it anyway. So that's the concrete on top, underneath. Let's go ahead and put concrete on top of it. Okay, of course I'll have to clean that up with a knife a little bit. Now that's only there. I'm going to do that one first, and then we'll do the diaphragm second. So in other words, we'll do a couple of testing showing you the rigidity, what happened in the middle there, and then we'll do the outside diaphragm, if you will. I guess I could do this side as the diaphragm fun one. We already know this is pretty taut, but we're going to tighten her up. Oh, I don't have my... I need to put a formwork under there. I can't have it to the base. I want to be able to remove the foam below as false works. Which means pretty much I got to get to it now because I didn't lubricate that. I didn't oil that. I didn't oil this, so that's going to be a bit of an issue if I don't break the bond. I don't want to change the set inside there either. I guess I'm just going to have to get it out with a utility knife or even a chisel after it sets. But we'll let this do its thing. I think the ratio is fair, but you know what? We'll have a little more fun. We'll give it a little more on top while it still can bond. For a little fun. A little fun, and we'll look on the underside of that. We'll see how that made out. You and I will both see if the foam wrapped around or not. And this will take a couple hours to get itself in shape. Terminating video. But now, I'm sorry, before I do that. So for clarity, I was giving you an idea of how things looked in the other video, how the load paths look under a free body diagram, if you will. Now you'll see how, in theory, how it really looks. This can't deflect if the bottom is in tension, compression rather. This is bonded now. It's all bonded, no ductwork. It becomes a bonded system. This should now make this act like a node, like that node. Should only react out here, mostly here and here, depending on how concentrated your load is down. But it'll change the point out to here and here as you push down on anywhere in here, anywhere in the center. It will now interlock, make it all act as one, but it still has a deflection there. Whether it would deflect it once you overload it with the load. But if you could only load one of these areas like directly down, it would normally break in tension at the bottom, but since this is a compressive product, it's holding in there, so when it tries to get tension to open it up, it can't, because the cable on the two ends, it's the two ends of the structure, or have a compressive force on it. So it's countering the act of it wanting to open. It's countering those forces by wanting to open by the compressive moment of the cabling. Let me see if I can get that right. The cabling pushing in at the bottom half of this. So I don't want you to think that I want you to visualize it how it really works. but you also see how the real load path works. Theoretically, what's really transpiring as you're pressing here. It's really radiating this way and that way, all directions, including down, obviously, depending on where your load point is concentrated from the base. At the base, or it could be at the top. If you got a wind load point that's kicking over, it still translates down to the base, but it'll give it a little torque on the bottom there. A little rotation. Okay, terminating video.